Cool, looks like everything's working. Hopefully we can see chat. Oh, excuse me. Hey everybody, Roll SK here. Welcome to Fix It Friday. Today we're working on this Neotech 2701 arcade CRT chassis. And yeah, this is the driver chassis for a cathode ray tube TV, high voltage AC device. And we're doing some pretty standard maintenance on it. We're doing a cap kit. And yeah, we just got some new components in today. So I'm gonna see if I can move that to the side. I'm gonna maybe turn the music down just a pinch, because it's kind of loud. I hope that's not bleeding through. All right. Anyway, yeah, we're repairing this Neotech chassis. And we're replacing the caps. And we're going to actually replace the horizontal output transistor, which is this doohickey right here. And when we get some people watching, I'll decide, demonstrate how we go about nice. Plus. Demonstrate how we go about testing that. But yeah, we're gonna do a cap kit, and these are the replacement capacitors we're going to continue to install. As you can see, I've got a list here, and the kit came in a bag of capacitors, and we've gone ahead and sorted them according to the list issued. And this task is pretty much just installing them. So we'll go ahead and do that. We'll go ahead and get started. Next on the list is P350. And for the best way to go ahead and find that is to use the manual, which I happen to have. And it shows the layout of all the capacitors. C350, where are you hiding, buddy? C350. Come on, C350. Okay, there it is. We'll reference that to... yeah, so it should be right over here, where C350 should be hiding. Next to there. Next to a big resistor. So it's next to a big IC. Which IC is that? IC 201. C350's got to be... where are you hiding? Just to the up of it. I'm losing my mind here. Okay, no, it's down here. C350. Oops. I'm dropping a crud on there. What's going on, Twitch viewers? I'm just repairing this arcade chassis. Looking for capacitor C350. I'm going to replace. We're doing a replacement capacitor kit on this, and we're also replacing the horizontal output transistor, which is fried because this ceramic cap 450 blew. So that's coming up, but right now we're just going through the cap kit here. C350. And I'm using the layout here that came in the manual for this Neotech monitor to identify and find, but they're labeled on here. Problem is there's hundreds of these fucking buggers. 23204. Oh, it's by the transistor. Yeah, it should be. We're right around here. Ah, right here. There's C350. Okay, so we're gonna desolder that, pull it out. We're using a soldering wick here that's got flux in it. And a solder wick is just it's a braided copper. Braided copper that basically, yeah, wicks the solder away. Is that RLG? What's up, RLG? RL Gamers? I probably pronounced it incorrectly. Oh yeah, I got a couple of RetroPies. Got a RetroPie powered Donkey Kong arcade system downstairs. And then just an emulator on the main TV, as most of us do. So again, yeah, just using the solder wick to desolder cap C350. Come on now. I got my soldering iron set to about 370. You don't really want to go much higher than that. Because start vaporizing lead. And if it isn't taken, just put a little dab of flux solder on that. Just help transfer the heat to that that wick. Okay, I think we got her. Gonna use my iron to debend the prongs a little bit on that cap. There we go. Try not to do what I just did, which is scrape too hard. To damage the pad a little bit. I damaged it on the right side to damage it though. So we're gonna flip it over and pull that cap out carefully. What you do not want to do is put any pressure on heat sinks or components because you can damage them. Now, where did I pull that out? There. E350, right there. Okay. So we pulled the cap. And it is 470 microfarad, 16 volt. And the replacement is 470, 16 volt. So that is considered correct. And we just pop that back in there, making sure we line up the polarity. It's marked the negative side. And on this particular board, the negative side is indicated by a black mark on the front side. So again, we flip that over, not putting any pressure on the neck board. You can see we've got those two prongs sticking out now. We're going to give that a little dab of flux. This is no clean flux. Pretty handy. Pull back on that syringe so it's drop a ton out. And yeah, I'm gonna just kind of gingerly reach under, and I'm going to straighten one of these legs. I've bent one to hold the cap in place. We're going to solder the straight one first. Don't have a solder sucker. Use solder pads and a board. Yeah, you can melt the solder pads for sure as well. Yep, for sure. That looks pretty good. Clean off the tip. Just gonna clip that off. Toss it in the garbage Tupperware container. Straighten that out. Well, give it a gentle tug, and she's ready to go as well. You don't apply too much solder. You don't want to make a mess of her. I'm just gonna add a little bit of transparency to the chat so I can see it a little better. Sorry, folks. One moment. One moment. The mic's gonna pop. I'm also gonna shut it off because there's speakers. Okay, added a little bit of transparency. I'm gonna get rid of this because that's probably not helping me see. I learned to do this by watching YouTube videos in practice and generally playing with electronics since I was a kid. But having the right tools helps. There's lots of good videos on how to do stuff like this. Okay, so that's 350 done. Now we got a few people watching. I'm just gonna show. How I've laid out my cap kit. Now, capacitors are typically something that blows in arcade chassis. They do that because they're filled with organic chemicals, electrolytic capacitors. It's basically a paper wrapped in, you know, some sort of capacitive component. So as these things heat cycle over the years, they tend to wear out. These capacitors tend to wear out. And they might not even show physical damage, but the tolerances and their capacitance can change over heat cycling time. So you can buy cap kits to fix old arcade monitors. They're relatively inexpensive. They're about 30 bucks. Usually come with a bag full of capacitors. For example, here's one for another monitor. And they usually come with a list labeled by capacitor. So what I've done is I've sorted through those and I've sort of punched them through some foam to indicate all the ones I need. I'm just going through the list. All right, so we just finished 350. And we got to do 406 now. So where the hell is 406? Like, they're all labeled. Oh, there's 406 right out there. Look at that lucky first guess right there. Okay, so again, soldering wick. And this is flux soldering wick. In this particular year of boards, like this is like a late 90s board. They went with a leaded solder, which tends to crack. as well. I don't really see a lot of signs of that on here. Okay, got that one done. But yeah, it's kind of like common practice, I guess, for people to just go ahead and resolder a lot of the joints if they get a failure. Okay, so we got to be careful here. We've desoldered an associated component next to this capacitor. Again, I'm just going to gently push on that, trying not to scrape the pad. Yeah, she's loose. 406 is loose. Okay, so we'll gently flip that over again, making sure we're not setting it down on any integrated components. There's 406 right there. That's 406. Ooh, that's 406. It doesn't want to come. Let's get a little bit more heat on the backside. Not uncommon for these things to be glued in either. Oh shoot, it already fell out. Oh, that's why. She just popped clean out. Okay, so we've got 1 microfarad at 50 volt is the one we pulled. And we're replacing it with a 1 microfarad at 50 volt. That would be correct. And we'll pop that in, making sure we align the proper negative terminal on the capacitor, because capacitors have polarity. And we just bend those tabs over. I'll show you guys that real quick here. Yeah, those tabs right there. I bent them over now that I've got that. I'm going to fix that autofocus. 1 second. 1 second, folks. Yeah, that should have fixed the autofocus issue. Sorry about that. Anyway, we bent the tabs over. We'll just bring that up. Hopefully you guys can see that. And we'll straighten one of those because we've got the capacitor sort of mounted flat on the other side of the PCB, which is what we want. Yeah, we'll straighten that one out. It's flush, it's flat. Give her a little dab of flux. And what flux does, folks, is that's what makes it want to stick. Makes that metal want to stick to that solder. Pro tip, solder flows towards heat. Okay, so that one's done. Now we're gonna have to make sure we resolder both of these components here. We've now done. Give the tip a little wipe there. All right, now we can clip those little buggers off. Okay, 406 is done. Next is 407. Might even be nearby. Oh, it is too. Right on. You're coming out 407. On the back of this board, the capacitors are indicated by a circle. And conveniently labeled. Something they don't often do with modern surface mount components. I mean, there's just no space. Can't really do it. Okay, give those things a very gentle push. Make sure their solder's broken. Good, it is. Okay, we can pull out 407. Again, flip it over gently. Making sure you don't put any pressure on any components. Your 406, we just did you. Your 407. Pull you out there, buddy. Okay, so there's 407. 1 microfarad at 50 volts. Replacement from the list is 1 microfarad at 50 volts. Once again, these have a polarity. There's a small stripe on there indicating the negative polarity on the capacitor. And on the board itself, there's a half circle that shows a black side. And a black side is the negative. So make sure you line those polarities up. You're doing a capacitor replacement kit on your arcade machine at home. Okay, there it's sticking out. Straighten one of the tabs. It's easier to trim off. It looks a little bit neater. Tab is straight. And again, we apply a little bit of flux. Pro tip, have some ventilation in your room. I've got the hood fan going, so we're sucking the air out of the room, because there are some fumes from the flux. And you should really wear gloves if you're going to do more than any small amount of this. Perfect. Okay, I'll get the other one now. Straighten her out. There we go. Another one done. Next on the list is 411. Is it in the area? Look for the circles. Yeah, it's right there. Perfect. Okay, now we just got the other side. Got it. Give her a little clean the tip. Folks appreciate a clean tip. So that's capacitor 411 we've desoldered there. And yeah, I guess I can show you that a little clearer now. This is 411 that we've just pulled out. And it is again, 3.3 microfarad at 50 volt. The replacement is 3.3 microfarad at 50 volts, so it checks out. So this is the capacitor. You guys can't probably really see that very well, but that's the cap. There's a white stripe on the side that indicates the negative polarity. This is where the cap goes. The dark side of the circle indicates, so make sure you folks can see that. There's a bunch of crap in the way. Right there. But the dark side of the circle indicates the negative side where the capacitor goes. So line up the stripe with the dark side. Pop it through just like that. Give it a gentle press down, make sure it's straight. And then gently flip the board over. Yeah, and we've got them right there. And I'm just going to give them a gentle bend out. And what bending them out does is it just sort of holds that cap in place. Gives us a chance to drop a little bit of flux on there. And solder. Okay, got a little bit of flux. We'll straighten out one of the terminals. We'll solder that one first. And we're using flux cord leaded solder here on this. That looks pretty good. Okay, now we can straighten the other one out. Now that's sort of held in place. I feel just make sure the thing is straight. Got it. Okay. Solder that one in place. And again, cleaning the tip of the soldering iron. If you don't clean the tip, it'll oxidize, which is not great. We do not want the oxidation. Flip off the capacitor tips. And there's another one replaced. Right there. That's the one we just did. Okay, so again, we go to our list on the cap kit. And we see that we've got a 412 that's got to go next. It's the next one right there. So we're going to look for 412 on the board. Number grouping could be right in the area. And C49, C7, C411, C14, C412 right there. Here we go. So again, we use our solder wick. Desolder C412. And the heat just draws the solder into that copper. Gary. Got it. Give a little push, make sure it's completely disconnected there. Careful, don't want to scrape any. What I did there was bad. Not want to scrape any of the traces. Gotta be gentle. Okay, so we gotta pull out C412 now. Where are you? C412. Yeah, right there. Check the reading. 4.7 at 4.7 microfarads at 50 volts. Replacement is 4.7 at 50 volts. Hallelujah. We have continuity. Pop that bad boy again. Again, just making sure we got the polarity correct. Flip it over gently. Add a wee bit of flux. With the flux, you really don't need very much at all. It'll run. It'll flow when you heat it up. Okay. Straighten out one of these. And I'm straightening them because it just looks cleaner when you trim them. Giving her the heat. Giving her the flux cord solder. It's a gentle tug there. Make sure it's good and straight. Feel it from underneath. Now I can do the negative terminal. Good enough. Good enough. Cool, another one done. So this board blew. It blew up because a capacitor failed, which shorted out the horizontal output transistor. And we are actually got to replace that as well. So you're curious, that's the horizontal output transistor. And we know it failed because we tested it. And how we tested it, hopefully folks can see that well enough. I'm gonna gently move this over. Test to make sure my pen's writing. Which it is not. I gotta grab a different pen. And I'll demonstrate how you test a horizontal output transistor, which is what these bad boys are. How TV works. And again, this is where a manual comes in handy. Yeah, and this is called a flow chart. This is basically a layout of the analog circuit, more or less. So, how a cathode ray tube works is basically it fires a beam of electrons horizontally, sweeping left to right, top to bottom, starting at the top, left to right, and it goes left to right, top to bottom once every, it's 60 hertz, so 60 times a second. And how this whole thing works is it's got a driver that basically fires the horizontal circuit, and then it's got another driver that does the vertical. And what the vertical circuit does is that's the one that outputs like colors and the synchronization and the brightness and things like that. So horizontal is always going, and the vertical is the one that says like green here, red there, bright here, dark there. And yeah, all of this translates into the circuitry here. So this is a horizontal output transistor that basically takes the low voltage oscillating frequency. I'm screwing this up. I'm not an electrical guy, but this thing is what drives the high voltage flyback transformer. And the high voltage flyback transformer is the thing that fires the high voltage into the TV that makes it work. They can blow because capacitors degrade or something shorts or the flyback goes bad or cracks or leaks. Flyback on this looks fine. This is fried. And how do we know it's fried? Okay, so we have ourselves a multimeter, and a transistor is, this is where I need a pen. I'll be right back. I'm gonna grab the pen. Okay, I've got a pen. All right, so the deal is typically a transistor, and I'm gonna screw this up, but typically it's a diode and like another leg. And you can look this up based on the transistor, but the gist of it is you should not get current flow through the diode, okay? It should short out and not give you flow. So we have the multimeter here set to 60 kilo ohms range. This is a good transistor. And if it depends on the polarity, and they change versus one. So you can see we've got no continuity there. No, but we do have continuity there. So this is the diode side. And we're showing 36, 35 kilo ohms. If we reverse the polarity on that, we get no flow because it's a diode. it will not allow current flow backwards through the diode, but it will allow it this way. So this transistor checks good, and it should, it's brand new. Here's the one I pulled out. And if I do the same thing, I get no resistance in either direction on any of the legs, which means this thing is fried. So this one's garbage. That's the replacement. That goes on the board. Awesome. Hey, what's up, Dark Avenger? Yeah, dude, we're still working on this Neotech 2701 chassis. And I just demonstrated how to test your horizontal output transistor in this specific chassis, which is bad. But we're still continuing the capacitor replacement project. And if you're watching, this is how we've organized our capacitors to replace. Given the list and the caps that came in the cap kit, we've just sorted through them and punched them next to all the right things. So the next on the list is C414. And we were working, oh, it's right there. Perfect. Great. Got it on the first try. Gonna trim this here. Oh. Okay, so there's C14, C414. And again, just like all the rest, we're gonna desolder it. We're gonna check its rating, make sure the replacement is the same rating. And if it is, we'll pop in the new one. Again, just using the solder wick to desolder. And a gentle push with the iron, making sure we're not scraping the traces at all, just to loosen that thing up and make sure that the solder is broken. Okay, flip it over. Careful not to put any weight on any components. Yeah, here's C414 right here. Oh, done dropped her. Where'd she go? Gosh darn slippery little buggers, I'll tell you what. Let's see that on, oh, there it is.
Groovy.
Oh, cool. Thank you for the follow, whoever just followed. Yeah, I know that the half the screen is darker because I was having trouble reading the chat, but actually now that I've moved, I could probably undarken that. Anyway, we just pulled this cap. It's 470 microfarad rated at 16 volts, which you probably can't see. And our replacement is 470 microfarads at 16 volts. It's correct. Now the difference between these, this is an 85 degrees Celsius rated cap. These are 105 degrees Celsius rated caps. So they actually have higher rating in terms of temperature. So make sure when you pop her back in, you align the polarities correctly and give those tabs a little bit of a bend to hold the capacitor in place. Gently pop it over. You can see there where I've thrown the new cap in. And thank you, Hybrix XD. Appreciate that. Yeah, I know half the screen is darker. It's, again, so I can see the chat better. Actually, but hold on. I'm going to fix that because I think now that it's darker in the house, I can see the chat better. Okay, I think that fixed it. Okay, so got the cap through. We're just gonna give it a little tiny dab flux in both terminals. This is no clean flux. Means it's not supposed to look super icky when you're done soldering. And that one we can actually hold up a little bit. So we're gonna hold that from underneath. Nah, it's still easier to hold it from the top. And again, we're just gonna give it a very gentle tug. Heat that puppy up. We're using leaded flux cord solder. It's gonna give that a gentle tug there while it sets, clean the tip. And why the gentle tug, you might ask? Well, we just want to make sure that capacitor sets in there nice straight from the top side. Okay, I think that feels pretty good there. We'll go ahead and solder the other terminal. Now that keeps loosening off, eh? It's not surprising. Now, don't overdo it with solder. You don't want to risk accidentally doing multiple traces, which would not be good. And once you've got that soldered in there, some snips and just turn those off. Perfect. Okay, C14's done. Next on the list is C415. Are you in the neighborhood? C412? Nope. C4? Nope, nope. One looks like it needs just a little more solder. There we go. All right, back to the list. C415, where are you hiding, bud? C415. There's 417 down here. So maybe we've moved over. So we did all those already. 415, where are you hiding, bud? C415, it's back to 103, which we're going to replace this filter cap as well. We've got a new one for it. 411, 412. We're looking for the circles here. 2. 650. You look like an utter disaster of a solder here, bud. Who did you? I think 550 was on my list. Give that a little shot of flux and resolder that one. That wasn't one of mine. Someone's done a little bit of work on this board in the past, but pretty minor. Go as far as to replace all the caps. That looks better. Okay, back to the hey, Alex Burks, welcome back. What song is this? Turn it up? I can turn the music up a little bit. 1 second. The song is The Fat Rat by Unity, or Unity by The Fat Rat. One or the other. Now back to the search. Oh, there it is. Perfect. You folks let me know if that's too loud now, okay? B415 right here. Just keep loosening off there. Again, using the solder wick to desolder the old capacitor. Still a little bit more in there. Still some more. Cool. Be able to pull that one out now. You make sure she's loose. Yeah, that one's good. In here, it looks like it's still a little tight. Come on, buddy. There you go. flip her up on her side to pull that one out. I think it's in a bunch of stuff, so I'm gonna have to use tweezers or pliers. Yeah, it's kind of in there. Okay, we got a 2.2 microfarad, 50 volt replacement. 2.2 microfarad, 50 volt. That's a winner. Now I'm gonna slide this bad boy back in there. It's actually gonna be easier because it's got longer terminals on the end of it. Got her. We got her. These out of the way from the chat there. Can't see it. Okay, there's our new cap in place. Give her a dab of the old flux. Grab our leaded flux cord solder. Put that bad boy in her place. Done. Another one off the list. Trimming those terminals off. Last thing you want is one of these suckers to get stuck on your board. Yeah, that would be bad. So before you power anything up, if you're doing work like this, make sure you give it the back end a thorough inspection, cleaning, get any sort of solder debris off there. God help you if you miss something. Because when you turn her on, she's gonna pop. Sorry, you heard me slurping there. Okay, C417 is next. And she's a bigger one. I don't like this either. Bend that back a little bit. Okay, C417, where are you hiding? Oh yeah, right there. Because we know it's a bigger one. Again with the solder wick. Snap, crackle, pop. Yeah, you don't want to let the smoke out. Last thing you want to do is let the smoke out. So we let the smoke out of this one. That's why I have to do all this work. Okay, get that one out. You desoldered, buddy? Yep. Yep, she's coming out. Good stuff. Being tough. Okay, so 100 microfarads at 160 volts is what's coming out. and 100 microfarads at 160 volts. What going in? So they do look a little bit different, but that's pretty typical because, you know, this stuff's 20 years newer. It's better. So it might be a slight size difference. The terminals shouldn't be any different on the bottom though. In you go. Yeah, see, it wants to be in there. There we go. That over. Give her a dab the old flux. Solder that puppy in place. Nice. Great success, folks. Great success. Okay, another one bites the dust. C426 is next. And that's right there. Perfect. Good. Give my hands a quick wash here. Getting a little bit sticky from the flux. Boy, you should wear gloves. Cool. Anyway, sorry, I gotta wash my hands real quick. Then we'll get back to C426. We're getting lower on the list though. Not too many. These are for the neck board. This is for another project. But then we'll solder in our replacement transistor and our replacement ceramic capacitor. And then we might even get to fire this thing up tonight. Yeah, I can give this hands a quick wash here. All right, this is actually for a 2004 golden tea cabinet for a friend of mine. Got everything in the cabinet up and running just fine. And the monitor decided it wanted to choke. One of the caps went. which would be caused by like a bunch of different things. And the cap and the transistor beside it went. So I'm just going to replace everything and then let the smoke out. And then let the smoke out. So there's cap 426. A lot of these old boards are meant to be serviceable, so they'll actually give you like the components and stuff on the back, which is kind of nice. But old unleaded solder and old capacitors do degrade with time. Same with the flyback. Some of these things run for like fucking hundreds of years and never break, but when they go, problems are pretty common. Okay, that one's out. That one's right on the edge, so we just, there we go. What do we got? 250 volt, 1 farad, 1 microfarad. And we've got a 250 volt, 1 microfarad. We have a successful candidate for replacement. We'll flip that up, check the polarity, make sure it's going in right. But when you do this kit, and it does pop, that's the first thing you're going to want to check is, did you actually put the... Did you actually do the polarity correct? Yeah, I've got a LCD powered main cabinet downstairs. 2 of them actually. Would love to have a CRT one. That would be sweet. Another new one. They're soldered done. Trim off those terminals as close as we can. Next on the list, 430. Are you in the same neighborhood? So 3, 604. Oh, 430 is way over here. Well, this is in the area where we had damage, so good. Let's pull that bad boy out of there. Got him. Got him. This one will definitely have to flip over. It's tucked way in there. Way down here. Oh god, it's way in there. Well, that's when you need these, folks. $10 farad, 50 volt. Replacement is 10 farad, 50 volt. Hallelujah. Now, to get this tricky bad boy back in there. Got it. Got it. Actually, this might be a good time for me to clean. A little bit of schmoo in there at the heatsink. I don't particularly want when I put the new one in. I've got some new thermal paste I'm going to use on the new transistor. Okay, how are we going to get in there on that? Try this. Yeah, there we go. That's doing a job. Schmoo. Yeah, that's pretty clean. Put that in the waste pile. All right, so we pump that thing back in there, vent her in place. Let's get her soldered. Rude of me to answer my phone. Winding up a Grand Theft Auto session for later. Yeah, don't zap yourself with the cathode ray tube. That's dangerous. Doop-a-doop-a-doo-doo. Nice. Sorry, that folks. Okay, so that's soldered in there. Let's trim off those leads. Those trimmed off. All right. So while we're in this area where I've got to do some other repairs, I think we should do some other repairs. Maybe it's time to pop in one of these ceramic capacitors. So ceramic capacitors are a little different from electrolytic capacitors. They quite often don't have a polarity, but some do. So if you're ever replacing those, you've got to be very careful about that. And we're going to install that the same way we installed the other one, carefully. This is actually, oh shit, I dropped it. This is one of the things that popped. I found fried, and I'm not sure if it fried blowing the transistor, which is likely, or if the transistor popped and blew this. We're gonna have to straighten that out a little bit. Okay, terminals look to be about right. Okay. Okay, that one's good. I'm not going to flip this one on its back this time. Oh, one thing I should point out. I've ordered like 2 of all the things that blew up, so that if I misdiagnose the problem, I can redo it. And I'm just squeezing some flux on here. You probably can't see that on the backside, but wee bit of flux. I'm just gonna make sure that's where it needs to be. Yeah, that's pretty good. Okay, let's solder that replacement component in place. Okay, let's take a look at our handiwork. Yeah, not bad. Solders look good. They look complete. That was cap C450 that popped. Oh, they do? If the ceramic cap's got a polarity, it's got a flat side? Yeah, or it'll be marked. A lot of them are marked. Okay, so time for the big guy. We're gonna pop this one in. Gonna go in like that, which means this leg is gonna have to be bent out a wee bit. And I'm just using pliers to do that. Ta-da! OEM replacement. So, we are going to use CPU thermal heat paste on the back of that thing. And I believe we have, yeah, we've got a screw. Got a screw we got to put through it. So, we'll put this a little bit of thermal heat paste on that first. Thermal heat paste. Good stuff. I'm not really worried about putting too much on here. Just gonna smear it around as well, just so we get full contact. This stuff is probably a bajillion times better than the stuff they used back in 1997 when this thing was manufactured. All right. Okay, we're gonna flip this over on its side. I'm gonna try to pop this thing in. Can't. Figure's too fat. So I guess I'm gonna have to use the pliers again. Not too much pressure now. Oh, damn it. Come on, get in there. Oh, I just had it. Need a third hand. Got it. Okay, good. Now we just got to feed the screw through. Come on now. Can't find the damn hole. Oh, that's because I'm going through the wrong fucking hole. Way to go. Making a fine mess of this. Oh, thank merciful Christ, I got it. Okay, so now should be a little washer to put on. This one we can hold in the pliers. And then I can turn the screw from the backside, I think. Oh my god, I think I got it. Yeah, I think we fucking got her, folks. Okay, that's in there. Now let's solder the shit out of that bad boy. And try not to get flux all over my tools, maybe? There we go. Let's not get flux all over my tools. You go back in the spare parts bag. And you can go over in the file. Same with you. Where is that? Ah, there it is. I think we got her. Got her. Now we tested that transistor, we know it's good. At least as well as we could. But I've got like extras if it's not. Okay, so back on the cap train. Now that we've done those two components. So we are looking for 501 now. 501. Where are you hiding? Actually, I'm gonna take a moment. Just clean up some of this flux here. It's actually not too hard to do. cool. No, I think we're okay. One second, folks. Gotta check something here.
Groovy.
Okay, I'm back. Sorry about that. All right. So, got the transistor replaced. We've got that ceramic cap, that blue replaced. We're now looking for transistor 501. Oh, where are you at there, 501? My dog's crying because she's temporarily afraid of the floor. Yeah, here's a IC 501, 504 cap. Oh, there we go. 501. 501, folks. She's coming out. We're gonna get rid of that. Gonna let my iron heat up. While it's doing that, my dad's coming by for supper, so I'm gonna move some things around so we can relax. Specifically, a microphone and shit in my living room. House is unmitigated disaster right now. Okay, that's done. Soldering iron is hot enough now, we can pull that component off. C501. Your time in this arcade cabinet is well over. Oh, I should trim that. Not sure why the image is blanking out. Sorry about that. Oh, look at that little piece of component there I left on the board. No good. Yeah, don't leave any chunks of metal on your boards, folks, when you're doing work like this. It's a good way to ruin a bunch of hours. And again, we're using a desoldering wick on these components. Flux soldering wick, I should add. The soldering iron is set at 370 degrees Celsius. It's about as hot as you ever want to get. I think we got her. Okay. I think we got it. Am I pulling on the right component? Ah, here she is. Okay, so 100 farads at 50 volts. And the replacement is 100 farad at 35 volts. So that's a discrepancy, but that's not unsolvable. The trick is just go to the manual. And component C501 right here is 35 volt rated. So in other words, we have the correct component. Now it's okay to go up in voltage for capacitors. As a general rule, I guess that's not a bad thing to do, but going down is a bad idea. But as long as the board is rated for that particular replacement component, we're fine. Okay, so a little dab of flux. Okay. Flux applied. Time to solder. We've just bent that tab over slightly on this side, and that's okay on this one. It actually solders to another component. Good to go. 501 replaced. Now we just got to trim. And she's trimmed. Next on the list, 502, which is immediately adjacent to 501, so we don't even really have to look. Figured that one was next on the list. Okay, 502. Your time is over. Thank you for your service. Oh, gotta put a little more heat on that. There, we got her. We got her. Okay. 2.2 microfarads at 50 volts. And this says 4.7. Wait a minute, 502. What the hell does the manual say? .4.7, 502. The capacitance is different. What does the manual say? Where's 502? Come on, it's got to be on the list. Sorry, folks, I just have to go through the list here. Okay, 900s. If I have any doubt, I just put it back in. Come on, C502. I know you're in the list. Yeah, 4.7. So, we're going to put the 4.7 in, because that's what the manual says. Ooh, stressful. Flip it over gently. Put it in, make sure to line up the correct polarities. Give the leads a little bend. And a wee dab of flux. To make sure my door's open because Dad's coming over. 1 second. Yep, she's unlocked. While I'm here, I'm going to put wood on the fire because my house is fire heated as much as it can be in the wintertime. It's the only way to rock it, folks. Wood heat if you got it. While I'm up, I guess I might as well grab a beer. Damn, this thing's gonna be ready for testing tonight if I keep at it. If I keep at her, I'm gonna actually be able to try to fire this thing up and see how much of the purple magic smoke gets let out. But until then, we're gonna keep plugging away at her. Come on, dog. My dog has decided she's going to be afraid of a part of my floor for a few days and is having trouble coming in the dog door. It's not unusual for her. So she's whining at me in the background. Well, I don't know what you want me to do about it, Dozer. You're afraid of the floor. That's not my problem. Okay, so that one's done. Next on the list is 504. So let's look in the same area because they tend to be grouped, which would make sense if you're a manufacturer. Put all the 400s and 500s in one area. Yeah, and there it is, 504. Careful now. C504. Okay, I think she's loose. I think she might be fucking running tonight. That would be exciting for me. You know what would be not exciting for me, though, is if I go to fire it up and it doesn't work. Gotta have the faith, folks. Okay, now where is Just desoldered you. How am I not seeing this? Oh, here it is. Tucked way in down here. Okay, coming out is a 50 volt 2.2. Going in is a 50 volt 2.2. Nice when the numbers work out. Yep, she's in place. A bit of flux. Squeeze on that thing too hard. And a wee bit of fluxed solder. Beauty. 504 replaced. I want to point out, folks, that I am an amateur. I believe anybody can do this themselves if they choose to. And tell you what, fixing things yourself is a faster way to get them done and surely cheaper. Okay, so next is C506. Are you in the same neighborhood, C506? I'm guessing you probably are. Snip off some of that wick. Here's 505. 551. C506. Where are you hiding, bud? Just want to help you be better. Ah, here you are. Out you come. Out you come now. Come on. Be stubborn. I think that's probably got her. Okay. Come on, C506. Oh, yeah. So coming out is a 4.7 50 volt. Going in is a 4.7 50 volt. That's what we like to see. Consistency. Weird that that one is a different capacitance though that we pulled out. I wonder if that is gonna haunt me. Guess we'll find out in an hour when I finish this. I may shut the stream down when my dad gets here. Depends on if he's okay with me doing this. While he's here. I told him I was working on stuff. He said, fine, we'll order some food in. Like, okay, Dad. Nope. 506 done. But yeah, I don't mind shutting the stream off. The old man comes by for supper. Don't want to be rude. Is that schmoo? Well, we got it. Okay, next on the list. 507. Are you a neighbor to 506? You sure are. Got it. Okay, removing 4.750, replacing with 4.750. You got a winner. Got a hot dog winner. Yeehaw. Okay, a little bit of dab of flux on that bad boy. I'm gonna move this up a little bit so you folks can maybe see a little better. That's where we're soldering. I'm done. Beauty. Nice. Next on the list, C508. Where are you hiding, C508? You're not hiding at all. You're right below C507. Well, that's convenient. Thank you. Well, that one wanted to go. Got her. 508. Out you come. And it is a 22 microfarad 50 volt. Replacement is a 22 farad 50 volt. Good. What we want. Put a flux on her. And we'll solder that thing in place. Done like dinner. Okay. Good stuff. Next on the list, 550. We've jumped a bunch. Where's 550 hiding? $550. Oh, we found 551. Oh, here it is. C550. Okay. So that one's actually been replaced in the past, but we've got a new one, so we'll toss her in there. Thought it could hide from me, did it? Every time you two are getting rough, my mind just sounds like Shia LaBeouf. It says no, 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 no. Just no, 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 no. Got her. C550. Your end is nigh. Weird. Checking manual time. Time to check the manual. Things don't add up, folks. Check your manual. Though we know this one's been replaced. Where the f did I put that manual? One second, I gotta find it. Put it down somewhere. Where the heck? Oh, here it is. Okay, so cap in question, C550. What does the book say it's supposed to be? It says 10 farad at 50. What a big one. BP, man. This one's 6.8. This is not a BP cap. Oh, it is BP cap. Okay, never mind. Technology has improved. Oh, look at that. Yeah, it's non-polarized. Oh, that's interesting. It's a non-polarized electrolytic capacitor. Oh, that confirms it's the right one then. Well, you learn something new every day, eh, folks? Learn something new every day. We'll put that little new one back in there then. Out with the old, in with the awesome new stuff.
We're back from the dead.
Hell yeah.
Sure that's twisted on there tight. Come here, dog. Come on. Come here, Dozer. Come. Oh, she's so silly. She's afraid of a section of my floor. I'm gonna go let her in the other door. Nice. Even that one gets replaced. Even that big bugger. BP, bipolar. That's probably what that means. BP, bipolar capacitor.
Back from the dead.
You gotta figure your shit out, Dozer. Not spending every day letting you in and out of door. You got a dog door. Dogs, I tell you, they're funny. Okay, so 550's done. We're on 551. Where's that one hiding? Oh yeah, we already found that one. This was over here. Yeah, right there.
Hell yeah.
We're back from the dead. Back from the dead.
Okay, 551 is now loose. Give that wick a snip.
Back from the dead.
Add it to our pile of junk. Okay, 551 is now loose. And it is a 100 farad 50 volt. Placed with a 100 farad 35 volt. But we've seen this before, it's the same cap. And when that thing blows up, I'll know why. Okay, cap installed. Dab it up with some flux. Solder that bad boy into place. Neat and clean. Another capacitor installed. Getting down that list, folks. And when you're snipping any metal off your board, make sure you find it, pick it up, take it off. Especially if you're doing some soldering with flux, because flux makes things a little sticky. Okay, 551's done. C603 is next. And that's way over here. So wait, 603. So it comes off next. Okay, 603 is a 10 microfarad, 50 volt. And the replacement is a 10 microfarad, 50 volt. So we know that one's a winner. Okay, it's way down on that side. Got her in place. Give her a dab of flux. And solder that bad boy right into place. Done deal. Trim off the extras. Four is next. And I think we saw that right around here. Yeah, here she is. Right next to this power cable, which will be in the butt, but we'll get past it. Take this solder wick. Okay, 604, 10 microfarads, 50 volts, replacement, 10 microfarads, 50 volts. That one goes right here. Okay, I think that got it. He's fluxed up. Take a sip of beer. 1 second. Hey, Dad. Oh, you brought takeout. Oh, wow, nice. Well, folks, I'm going to have to shut her down for now. I'm RollSK. This is Fix It Friday. I'll see you guys all soon.